Are we recording? Okay, so question 6. A team from Royal Hotel have challenged a team from the Carlton Hotel to a darts competition. This is so exciting. In this competition there are 7 rounds and the team must choose a player for each round, although players may play more than one round. Now, it's just they're throwing words at you. Each round is made up of 5 legs, and the team that wins the most legs, out of 35, because 5 rounds, 7 things altogether, or whatever, 7 rounds with 5 legs in each, there are 35, wins the competition. On the basis of their performance so far, the number of legs that each member of the royal team can expect to win out of 5 against each member of the Carlton team is shown below. The teams want to choose which player to put in for each round to maximise the number of legs they expect to win. If the royal team chooses Greg and the Carlton team chooses Jeff, what we're doing, the royal team chooses Greg and the Carlton team chooses Jeff, then that's the number that comes up. How many legs will the Carlton team expect to win? So what's this showing here? The diagram is showing how many of the royal team expect to win in each round. And each round is made up of 5 legs. So this shows Greg winning 2, so that means Jeff must have won the other 3. Are we happy with that? Greg wins 2. So Jeff wins 3. Well done, Jeff. Right. Convert the game to a zero-sum game. To convert the game, each value is in the table is doubled, and then 5 is subtracted. Construct the resulting table for the zero-sum game. So that we just need to follow the description, don't we, and do what they said. That was the original table. Oh, that's nice of them to put it there. So each one was doubled and 5 subtracted. So we're going to get 4 to the 5 minus 1, 6 to the 5 is 1, 8 to the 5 is 3, 3, 1, minus 3, minus 3 again, minus 5, and that must be 1. There we go. So that's our matrix. Then it says, on the next page now, find the place A strategy for this zero-sum game. Showing your working, explain how you know that the game is not stable. State the player is best for the Carlton team if they know that the royal team will play safe. But let's make sure that we answer this in order here. So we've got to copy our network out, our matrix out again, haven't we? Because that's what we had. As long as we got this right. Okay, so what we need when we're doing this is we need the row minimums and the column maximums. Because we need to know the worst possible outcome for each player. So the worst possible outcome for Greg is -1, for Hakim is -3, and Iona is -5. And we're choosing the biggest row min. We're choosing the least worst option, aren't we? So that one is the place A strategy for the royal team is Greg. Okay. We're choosing the column maximums. Because the column maximums, that's the worst thing for the Carlton team. So that's going to be 3, 1, and 3. And we're choosing the smallest of these. So it looks like Kathy is the place A strategy for the Carlton team. Now, if this was a stable solution, these 2 values would be exactly the same. And they're not. 1 does not equal -1, therefore not stable. If this was a stable solution, it'd be exactly the same. Then, the final bit of this question had said, find State which player is best for the Carlton team if they know that the Royal team will play safe. So we're now changing it a little bit. We're saying the Royal team, we're going to assume Greg is always going to play for the Royal team. So what's best for the Carlton team to do? Well, if you look at Greg's row there, if the Carlton team play Leo, Greg wins 3. If they play Kathy, he wins 1. If they play Jeff, he loses 1. So that's the best thing for the Carlton team, isn't it? Carlton team should choose Jeff. If Royals choose Greg, Carlton should choose Jeff. There we go. Okay. Right. Are we happy with this? And can we have we got the relationship between this and our original table? So you know what we did in part one? We said if it's Greg against Jeff, Greg wins 2 and Jeff wins 3. That resulted in 2 for Greg and 3 for Jeff. And look how it relates to this table. That kind of makes sense now, doesn't it? Because 2 against 3 is -1 for the Royal team. So that's what the table is telling us. It's telling us how many more than the Carlton team the Royal team are winning in each situation. Right. What we asked for next. The Royal team. Oh, sorry. We've got another thing to do here. Use a dominance argument. This is part 4. To explain why the Royal team should not choose Iona. So we've got to look at this. Why should the Royal team not choose Iona? Well, that's all about deciding if there's a better player for them in each case. And so what we should notice from this, well, it's not better for them to choose Hakim, because okay, he does better if it's Jeff or Kathy, but if Leo is playing, he actually does worse than Iona would. So it's not about those two. But if we look at Greg and Iona, then if that's -3, -1 is greater than -3, 1 is greater than -5, and 3 is greater than 1. So whatever happens, they do better choosing Greg. Does that make sense? So for our part 4, we need to say that Greg row dominates Iona as -1 is greater than -3, 1 is greater than -5, and 3 is greater than 1. So we've shown that in each case. Part 5 we are now on to. The Royal team. The Royal team chooses a player for the next round by using random numbers to choose between Greg and Hakim, where the probability of choosing Greg is P and Hakim is 1 minus P. Show that the expected number of legs that the Royal team win when Carlton team chooses Jeff is given by 4 minus 2P, and find the corresponding expressions for when Kathy is chosen, when Leo is chosen. Okay. So this is shall we do it over here? Yeah. This is that classic bit that we're setting up the graphical problem for us to solve. So what we had is, I thought I moved that. We had Greg and Hakim. This is the table we're left with. Jeff, Kathy, Leo. The numbers were 2, 3, and 4 in that row. And is that right? And 4, 3, and 1 in that one. Because we've gone back to the expected number of legs that the Royal team win. Have you noticed the slight shift in this? So instead of it being the zero-sum game, where one person, we were finding the difference between the winnings. The question has said that's why they highlighted legs there. So the expected number of legs that the Royal team win. So we've got to go back to this table. Okay, and now we set up our equations. This was P and this was 1 minus P. So we say if they choose Jeff, then it is now we're looking in this case for what are we looking for? The winnings for the Royal team. The Royal team winning. So we want the positive things from here. So it would be 2P plus 4 times 1 minus P, which gives us 2P minus 4P minus 2P, and that was given, wasn't it? So we've confirmed that we're doing this right. If it's, what was the name of that one, Kathy? Then it's 3P plus 3 times 1 minus P, which gives us 3. Because that other bit will cancel out. And if it's Leo, then it's 4P plus 1 times 1 minus P, which is 3P plus 1. So those are the 3 expressions in part 5. Part 6 says use a graphical method to find the optimal value for P. So they gave us the axes for us to do it, drawn exactly as we'd want them. So we've got to plot these 3 things. So the Jeff one is 4 minus 2P. So when it's 0, it's at 4. When P is 1, we're at 2. So that is what the line would look like for Jeff. Kathy, it was just 3 all the way across, wasn't it? So we're going to draw the line for Kathy. That looks like that. And Leo was 3P plus 1. So when P is 0, that's at 1. And when P is 1, that would be at 4. So this one is looking like that. There we are. And that is Leo, 3P plus 1. So our question now is, if we're doing the play safe, the optimal value of the play safe strategy for this one is the least worst option, isn't it? So we want to find the least worst thing that can happen. So we're thinking about the very bottom part of that region there. And the bottom part of that region is the point where these 2 lines intersect. So we're thinking what happens when 4 minus 2P equals 3P plus 1. And that gives us 3 equals 5P, so P is 3/5. That's the optimum value of P that we were looking for. And what does that mean? Well, if we sub that back in, that gives us either one that we sub it back into, 4 minus 2 times 3/5. That's 4 minus, what is that, 1.2, so that's 2.8. So that's the answer to our final bit. How many legs can the Royal team expect from this value of P? Expect to win 2.8 legs. That would be the average over a longer period of time. Finally, suppose that instead, here we go, changing everything now for one final mark. Suppose that the team that wins the most rounds wins the competition. The winner of each round is the team that wins the most legs out of 5 in that round. And there are still 7 rounds in the competition. Give an example to show that it's possible to win the most legs without winning the most rounds. Well, how does that work? We're just going to think through what that would mean. That would mean Well, that must mean that it must be close in terms of winning the most rounds. You know, that must be a kind of fairly close decision. But what if the team that won the most rounds, so won the competition, they were close each time, but when they lost a round, the other team dominated that round, so they won by a long way. How would that play out? So what could we have? You've got 7 rounds in each leg there, so that let's say that one team wins 3-0, because if it gets to 3-0 you stop, don't you? 3-0. There we are. So they've won 4 out of the 7, so that's enough for them to win altogether. And then, what about if the others were? Hang on, is that the way that we want it to be played? Yeah. If the others were, no, I want to do the way around, don't I? Hang on, let's think this through. So the team, it's only 1 mark for all that. One team needs to win the most legs without winning the most rounds.
Yeah, round.
So I want that one to be a loss as well. Let's do it that way. So there, if that's 2-3, then that would that do it? So that way, this team has won 17 legs, and this team has only won 12 legs, but they've won 3 rounds, and that team won 4 rounds, so that team was the winner. There are probably other ways that we could have done that, but that's how it was working. There we go, and that's maths.